Okay, so the ones that you got wrong prior to number 16, we did go through those. So I'm going to start with number 16. If you read the question, it says that segment AB is the perpendicular bisector of CD. So what I would probably start doing is just drawing CD. So if I draw CD, here's C, here's D, and then it says AB is the perpendicular bisector. Remember, a bisector cuts something into two equal parts. So there's the middle, and perpendicular means that it comes this way. We've got right angles. Okay, this would be A, this would be B, and then this is M. Okay, now it says which statement is always true. Okay, you can kind of eyeball this one. So if you look at choice one, it says that CB, which would be the distance from here to here, is equal to DB, which would be the distance from here to here. Okay, so I'm going to draw that just so that you can see that. And again, use your eyes. If you have contacts, make sure they're in. And you'll see that those two are definitely equal. So there's your answer. Now, just, in case you aren't really quite sure, there is something that you learned when you were doing geometry proofs. And if you have a bisector, that would mean CM and DM would be the same size. And the other thing is you should notice that MB is a side of this triangle on the left, and it's also a side of this triangle on the right. So that means MB is equal to MB by reflexive. Okay, what does that mean? That means this triangle here is equal to this triangle here, okay, by side angle side. Now, remember, we've got two right angles here. So if we look at it from this perspective, side, angle, side, side, angle, side. Okay, and so since these triangles are equal to each other, CB would have to be equal to DB. But again, I kind of like the cheater eyeball it method. Okay, let's look at number 17. I know we did this one, but remember, if that angle C is 70, that means that this arc is 140. It's double, which means this angle is 140. Okay. Now remember, if they're asking, I should say, the area of the sector, then remember, it's the portion of the sector always out of 360. Because if you look at this is like a circular, think of like a pizza. Okay, this is probably, I don't know, a couple of slices here out of an entire pie. Okay, so a couple of slices out of an entire pie. And then the rest of it, just look on the formula sheet, pi r squared. So it's the section times pi r squared. Okay, all right, and then we're just going to do 140 over 360 pi, and then I think they told us, here it is, the radius is 9. And you throw that in your calculator, and you are going to get choice 4. Alrighty, 18. So it says quadrilateral best. When you're labeling it, you can start wherever you want. I'm going to start right here, and then I'm going to put the E here. If I do that, then I need to continue going around in a circular fashion like this. So in other words, I can't put the S here. It's got to go here. Okay, so whenever you're labeling any kind of a figure, you want to go in a circular fashion. B-E-S-T. You could have gone B-E-S-T that way. You could have put the B over here, but you get the general gist. All right, so anyway, it says quadrilateral best has diagonals that intersect. All right, so here's a diagonal, and here's a diagonal, and they intersect at point D. Which statement would not be sufficient to prove it's a parallelogram? Well, I know if you have a parallelogram, the diagonals bisect each other. So what that basically means, and let me put this in a different color so you can see it. This piece here is equal to this piece, and this piece here is equal to that piece. Okay, so I'll repeat. Parallelogram, diagonals bisect each other. So let's look at this. BD equals SD. That's true. ED equals TD. That's true. They want to know what's not true. Okay, so since that is true, this is not the answer choice. All right, let's look at the next set of answer choices. BE is equal to ST. BE equals ST. True. Opposite sides of a parallelogram are equal. All right, ES equals TB. Yes, that's also true, which means that's not the answer choice. All righty, let's look at choice 3. ES, that's this top, equals TB. That is true. Opposite sides in a parallelogram are equal. Then it says BE is parallel to TS. Now, listen, that is true. But to prove something's a parallelogram, you would have to say that pick a set of sides that are equal to each other. So let's look at these two, ES and TB. But then you'd also, if you wanted to go with this whole parallel thought, you would have to say ES is parallel to BT. So in other words, if you say ES is equal to TB, then you'd have to say ES is parallel to TB. Okay, because in a parallelogram, you could have one pair of opposite sides that are both equal and parallel. And that is not what choice 3 is saying, so there's your answer. Okay, so if you haven't read the question, pause, read, and then turn me back on. So what I did was I just drew the dilation point. Okay, now we have a scale factor of 2, which means something's going to get larger. It's going to double in size. What you want to do when you do a question like this, you kind of want to think of like a megaphone. And you know how a megaphone starts at a point, kind of like a cone, and it opens up. Well, here's your point, and what we're going to do is open up. And here we're going to open up. So we always are going to have the new line, the new image. It's going to be twice as big, right? But it will always be away from this. So moving in the direction of the original and then past it. Moving in the direction of the original and then past it. So this is actually not hard. So because it's a scale factor of 2, what I'm going to I'm going to do twice. So this is what I'm talking about. So what you're going to do is you're going to just start at your dilation point, and I'm going to count how much it takes for me to get to A. So in other words, it takes me 1 down, and then 1, 2, 3, 4, 5, 6 to the left. Now I just did that once, right? Now I'm going to do it twice because it's a scale factor of 2. So I'm going to go down 1, and then go 1, 2, 3, 4, 5, 6. Right here, that's A prime. So there's A prime. So again, down 1 over 6, that's 1 time. Down 1 over 6, that's 2 times. If this scale factor was 3, I go down 1 and I go over another 6, and I'd be like all the way out here somewhere. Okay? All right, well, if you didn't figure it out, we're going to do the same thing for B. So I'm starting again, always at that dilation point, and I go down 1, 2, 3, and then I go over 1, 2. Down 1, 2, 3, and then I go over 1, 2. And there's your B prime. Okay, so again, down 3 to the right 2, that's once. Down 3 to the right 2, that's twice. Again, if the scale factor was 3, I'd go down 3 over 2 and do it again. So this, not that it didn't ask you to graph it, but just so you can kind of see, there's A prime, B prime. Now what they wanted were the coordinates of A prime and the coordinates of B prime, which would be choice 4. Because remember, when you're plotting points, you always start at 0, 0. And let's say for A prime, I'm counting 9 to the left, then up 3. And for B prime, I'm counting 7 to the right, and then down 1. And that's why it's that. Alrighty, so for number 29, I just drew the picture according to what they gave me up at the top, and they want to know, or actually, Brett claims that these two triangles are equal to one another. And he also says that they're similar to one another. Okay, so let's just start with this. I know that this side here equals that side there, but I don't know what this is. I don't know if it's 13 or not. and I don't know what DE is. I don't know if it's 5 or not. So when I have right triangles and I'm looking for sides, I think Pythagorean theorem. So I'm going to do a squared plus b squared equals c squared. Now remember, c has to be the hypotenuse. So in this particular triangle, I don't have the hypotenuse. So I'm just going to keep it c. When I put this in my calculator, I get 169 equals c squared. Now remember, I'm looking for c though. So I'm going to have to take the square root of both sides because that is the opposite of squaring is square rooting. That's going to cancel this guy right out. Okay, so that's going to disappear, and the square root of 169 is 13. So what I just found was that that is 13. Well, that's pretty good news because this matches this, right? Now we do have to figure out DE. Okay, so let's go ahead and do that. So we're going to do the same thing again. So we're going to do a squared plus b squared equals c squared. But this time, I actually have the hypotenuse. It's 13. And you can put the 12 either in for a or you can put it in for b. It doesn't matter. So this is 144. This is 169. Then I'm going to subtract that 144 over. And I'm going to get b squared equals 25, which means b is 5, right? Because I'm taking the square root. All right, so right here, b is 5. So now you can see 12 is equal to 12, 13 equals 13, 5 equals 5. So it says, Brett claims, I'm just reading this part right here, that the two triangles are equal. And it says, is Brett correct? I'm ignoring this for the moment. So yeah, he is correct. Now, explain why. If you can't remember it, you can kind of fake it, but basically this is side, 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 if you remember that, okay? If you don't remember it, you're going to say, yes, the two triangles are equal because all the sides are equal to one another, okay? Something to that effect is fine. Okay, all the corresponding sides are equal to one another. And you could say side, side, side. That would be quicker if you remember it. All right, now let's talk about this. He's also saying that he thinks that the triangles are similar. Is he correct? Listen, similar basically means that all your angles are equal and all your sides are in proportion. Well, if two sides are equal, they have to be similar. Wait, let me say that again. If two triangles are equal, then by default, the triangles will also be similar, okay? So if you look here, I said that all the corresponding sides are in proportion, meaning 12 over 12 equals 5 over 5, okay? That's a proportion. Let me just show you if you're not following what I'm saying. And you don't need to show this, but just to show you. 12 over 12 equals 5 over 5. Well, look, if you cross multiply this way, you get 60. And if you cross multiply this way, you get 60. Check. That means all the corresponding sides are in proportion. Now, I picked 12 and 12 and 5 and 5. I could have done 5 over 5 equals 13 over 13. I'm still going to end up with two numbers that are equal to one another. Okay? So if triangles are equal, they have to be similar, okay? And I also did say all the corresponding angles will be equal. So like if you look here, if this is 90, that's 90. Okay, that's it. Alrighty, so here's number 30. I shaded the two bases. Here's the bottom, there's the top. You have to be very careful with this one. It says one of the legs, I'm sorry, I'm reading right here. It says the base of the prism is a right triangle with one leg whose measure is 5. So here's the base, meaning this could be 5 or this could be 5. This is the hypotenuse, so that is not considered a leg. It's called the hypotenuse. So you could make this one 5 or you could have made that one 5. Now it says the height of the prism. So this is the height of the prism here is 4. And determine and state the length in inches of the other leg. So right here. I don't know why I called it H. You could call it any letter you want. Oh, I know why I called it H. And I'll tell you in a second. All right, so they tell you that the volume of the prism is 70. That's really important. I haven't seen a question like this. This is interesting. So what I did was I was like, all right, well, I know the formula for the volume of a prism is on the formula sheet. and its volume equals the area of the base times the height. So then I was like, all right, volume, the area of the base is a triangle, so that's 1/2 base times height. And then this h here is the height of the prism. So let's be super careful, and I hesitate to do this. This is the height of this triangle. This is the height of the prism, okay? Now, they gave us the volume. So right up here, it's 70. So I'm putting that in right away. So this is 70 equals 1/2. All right, so 5 times h. I'm going to repeat myself. This 5 is the base. This h is this one right here. This is the height of the prism, which is 4. So that's what I'm going to put right here right now. Okay, so I'm going to put a 4 here. Now, the rest is basic algebra. So all you're going to do is multiply 1/2 times 5 times 4 on that left side. Okay, and when you do that, you're going to get 10h. Divide out the 10, and h equals 7. So there's your answer. Okay, so for the first part, it says to prove it's a right triangle. So I'm looking at observing here, and I'm kind of thinking there's a right angle right here. And so I know to prove something is a right angle, that would mean they're perpendicular. So that would mean DU and UC would be perpendicular to each other. And I know that by doing slope. Okay. And so then when you look here, I did my 2 slopes, and I see that these guys are negative reciprocals of each other. And I would say something to this effect. So DU is perpendicular to UC because the slopes are negative reciprocals, which that means then angle U is 90 degrees. And then angle DUC is a right triangle. Okay, now in the next part, it says the point U is reflected over this line DC, meaning this is going to get reflected over here somewhere. Okay, and it forms what they want us to prove is a square. So I want to be very careful on where U is going to go. All right, so U prime is going right here at 6, -3. Now the way I got that was I knew that this side here would have to be parallel to this side. So what I did was I just counted 1, 2 down, and then I counted 1, 2, 3, 4, 5, 6, 7, 8, 9 over. Okay, so I did the same thing here. 2 down, 9 over, and that landed me right here. Okay, so then the last part is asking you to prove that it's a square. Okay, now with a square, you should know that all sides are equal and you have a right angle. Well, listen, you don't need to reinvent the wheel. We already proved that we had a right angle over here, so we can use this. We don't need to rewrite it, but we do need to prove that all of these sides are equal. And the way you prove all sides are equal is by doing the distance formula. So you're going to have to do the distance formula 1, 2, 3, 4 times. So maybe you want to pause me, do it, and then unpause and see how you did, see if you got it right. Alrighty, so here we go. Please do me a favor when you're doing this, especially the day of the regions, because I'm sure there's probably going to be a question, not exactly like this, but that requires you to do slope and distance. Tell whoever's grading your paper, oh, I'm doing the distance formula for DU. So like this, don't just write distance equals and then they have no idea what you're referring to. The same thing up here. If you're doing slope, you have to tell them what side you're doing the slope of. Okay, so now, remember when you're putting this in the calculator, don't put the radical in the calculator. You can open the parentheses, then do -3 minus -1, close the parentheses, square, plus, da-da-da-da-da-da-da, but don't put the radical, because we're going to keep the radical in the answer, it's fine. The goal is just to see that all 4 of those are the same. So you can see that you have a square because you've got 4 equal sides and you've got a right angle. That's what makes a square. And there you go. Okay, so you're just saying a quadrilateral with 4 equal sides and a right angle is a square. Period. End of story. I would really think that you're probably going to get a question like this on your Regents. So do make sure that you go over all those formulas on your formula sheet. And know that parallel lines, that means you do slope and the slope should be the same. Perpendicular lines, you should do slope and their slopes will be negative reciprocals. If you want to find the length of something, you do the distance formula. Remember, you're not getting these formulas. You have to memorize them. All right, that's it.